chemistry.
So,
You're going to help me with my problems today?
yeah.
Goodness. We're doing the practice problems for Module 13, and this video begins with number 3.
A chemist does a reaction rate analysis of the following reaction. C4Cl9OH plus F negative yields C4Cl9F plus OH negative. He collects the following data. It's the second chart on page 489.
Mm-hmm.
What is the rate equation for this reaction?
Okay, so we're going to say R equals some constant K times the concentration of C4Cl9OH to some X, which we'll figure out in a moment, times the concentration of F negative to some exponent Y, which we'll figure out in a moment.
Mm-hmm.
So let's look at how the data appears. When does the concentration of the C4Cl9OH change?
Between 2 and 3.
Yeah. And what happens to the reaction rate?
It doubles.
Okay, so when the concentration doubles, the reaction doubles. What does that tell you about the coefficient, the proper coefficient for that concentration?
It's 2.
Well, it's 2 and 2, so it doubles and it doubles. That means that X equals 1, right?
Yeah.
Okay. How about the F negative? When the F negative changes in concentration between trial 1 and trial 2, it doubles. What happens to the reaction rate?
It stays
Nothing,
the same.
which means it stays the same, which means that that coefficient is 0. Meaning it does not affect, the concentration does not affect our reaction rate. Okay.
Mm-hmm.
So now we have to solve for K. So let's plug in some concentrations in the reaction rate. So let's use trial 1. So the reaction rate, can you read that to me?
0.0202.
And that's molarity per second.
Mm-hmm.
Equals K took the concentration of C4Cl9OH.
0.25.
Molarity.
Yeah.
That's only to the 1, and this to the 0 is 1, so I'm just going to ignore it in my equation. So K is going to be this number divided by this number. So what's going to happen with my units? So I'm going to cancel this, and I'll just have 1 per second. So let's do the calculation. It's pretty straightforward division, and you can use the calculator for this, or you cannot. It's actually pretty easy to do without a calculator.
It's 0.0808. Seconds.
Yes, it's pretty quick to do with that as well. How many significant digits do I want to have?
2.
Yeah, only 2. So I'm going to turn my 808 10,000ths into 81 thousandths, right?
Yeah.
I'm going to say 0.081 1 per second. So my rate equation, now we can go back and write the correct rate equation.
Yeah.
The instantaneous rate of reaction will be equal to this constant 0.0811 per second times the concentration of C4Cl9OH. Okay?
Yeah.
We don't need to include our exponent because it's 1, but you can write it if it makes you more comfortable. Okay, I'll pause this and we'll do a separate video for number 4.